Hey guys, welcome to another video for Trig. I decided to cut the Trig Identities problems from 5.2 in half. I'll be working out 4 problems in this video because the last one was 8.5 minutes, so I wanted to make the videos a little more respectable in terms of length. So yeah, that's why you have part 2, I guess you can call this. So without further ado, let's go ahead and jump in. So let's look at number 9. Number 9 reads cosine theta over 1 plus sine theta plus tangent theta, and then we want to verify that this equals secant theta. Okay, well, so as I look at this, I look at the term on the left. The thing that pops out to me first is tangent theta. I know that tangent theta equals sine theta over cosine theta. And then I have plus cosine theta over 1 plus sine theta. So the next thing that comes out to me is that I want to rewrite this problem with a common denominator because I have 2 denominators that are different, so that's keeping these terms apart. So let's put them together. And of course, to do this, I need to multiply my right term by 1 plus sine theta. So that means I need to multiply this by 1 plus sine theta. And then my left term I need to multiply by cosine theta. So both numerator and denominator by cosine theta. All right, so let's clean this up. Let's see what this looks like. Now let's keep in mind that I have a common denominator now. So my common denominator is cosine theta times 1 plus sine theta. Now I could put these together, but let's just hold off and wait right now. Let's see what my numerator looks like. So my numerator looks like cosine squared theta plus sine theta times 1 plus sine theta. All right, so this looks kind of messy, but it is together. I do have a common denominator, so that's actually good. Let me clean this part up right here. I think I can put that together. So I have cosine squared theta plus, and then I distribute this term into both terms inside of my parentheses. I end up with sine theta plus sine squared theta. All right, all over cosine theta times 1 plus sine theta. So I have this all under a single fraction, which is good. As I look at this, I'm looking at the numerator. I'm wondering, what can I do in the numerator? Is there anything there that resembles anything in my trig identities? And yes, I look at sine squared theta and I look at cosine squared theta. Now, luckily, all of these terms are being added together, so I can actually flip them around. I can switch them around. I can do cosine squared theta plus sine squared theta and then plus sine theta. Now, cosine squared theta and sine theta is actually a Pythagorean identity. This equals 1. So I can actually clean this up. This is actually quite helpful because now I have 1 plus sine theta over cosine theta times 1 plus sine theta. Now, I hope it's obvious right now that I can actually cancel out a big chunk of this. I can cancel out 1 plus sine theta and 1 plus sine theta, leaving me with 1 over cosine theta. Well, that's pretty well simplified. So I'm going to go back and look at my original problem and or what this is asking me to verify, and it's asking me to verify that this equals secant theta, and yes, in fact it does, because secant theta is a reciprocal property equaling 1 over cosine theta. So yes, we have succeeded for number 9. All right, well, let's move on to number 11 then. Let's see here, number 11, 1 over 1 minus tangent squared theta plus 1 over 1 minus cotangent squared theta. And I want to verify that this equals 1. I can already tell this is going to be messy. Now, we've been talking about how when we see a squared and a 1 or something minus a 1 with the squared, that usually is a tell sign of a Pythagorean identity. But when we examine this closely, this actually isn't the case in this case. For example, let's see here. Let me just work it out for you so we can see. Because tangent squared theta plus 1 equals secant squared theta. So that's what we were hoping for, right? That this would be secant squared theta. But you'll notice here that it's tangent squared theta plus 1. And here we have 1 minus tangent squared theta. I mean, I guess I suppose we could factor out a negative sign. And that negative sign, that would give us a... No, that still wouldn't work. That factoring out a negative sign would be plus, minus. Yeah, it still wouldn't work if I factored it out, because that would be, I would have a minus a tangent squared theta minus 1 still, and that's not going to work. So it won't work, unfortunately. So this is going to be quite a messy problem then, because I'm going to have to work it out as it is right now. So let's see here. Tangent squared theta, I can use my quotient identity, and I can have 1 over 1 minus sine squared theta over cosine squared theta. And then my next term here would be 1 minus cotangent squared theta. It would be cosine squared theta over sine squared theta. All right, so it looks like I may have made it more complicated, but this is actually the only way that I can think of that we can approach this problem. But here's the thing. Here's a cool thing. If I look at this one here, and I can do the same thing with this one here, but let's just focus on the left side here. Notice that with 1, I want to give all of my denominators, all my denominator a common denominator. So 1 I can actually convert to cosine squared theta over cosine squared theta. That's still 1. I haven't broken any math rules. And then minus sine squared theta over cosine squared theta, right? So you'll notice here I have now a common denominator. So that helps me out. That helps me out in simplifying this. So my new term on the left side is 1 over cosine squared theta minus sine squared theta over cosine squared theta, right? Okay, so let me do the same thing to my right side here, my right term. And again, keeping in mind that this is all going to equal 1 eventually. So on my right side here, I have 1 over, and so as I'm looking at my 1 here, I need this to have a common denominator of sine squared. So I can change it to sine squared theta over sine squared theta. Still 1 minus cosine squared theta over sine squared theta. All right, so I'm doing good so far. I have a common denominator. So let's keep moving. We're going in the right direction. So 1 over sine squared theta minus cosine squared theta, all, and then this over sine squared theta. Let me get rid of these marks here. I feel like they're confusing me. Because I should actually have these marks over this, because it's all under 1. And that's the problem, actually, that I look at this. All of this is under 1. So that means my green term is all my denominator. And it's a fraction. My denominator is a fraction. And luckily, my numerator is just a 1. So I can actually just flip it. And by flipping it, what I end up doing is that I'm doing 1 divided by all of cosine squared theta minus sine squared theta over cosine squared theta. And of course, you know the rules of multiplying fractions. I end up flipping this back to its reciprocal, giving me cosine squared theta over cosine squared theta minus sine squared theta. Right, so you see what happened there? I can flip it here by multiplying by reciprocal, and I can only do that because this is all in a denominator position, so it does flip conveniently. And the same thing can happen here. So here's my new problem. I have cosine squared theta over cosine squared theta minus sine squared theta plus sine squared theta over, well, that's a little bit different, it's not the same thing, over sine squared theta minus cosine squared theta. Okay, so my goal here, I guess we've forgotten, is to get a common denominator. So I don't have a common denominator, but there is a way, because my cosine here is positive, but my cosine here is negative. My sine here is negative, but my sine here is positive. The easiest way to do this is to just change the signs of one of these terms. And I'll go ahead and just change the sign of this term here. That means I'm going to flip all the signs. So what that means is my numerator is positive sine squared theta. Now it's negative sine squared theta. And then my denominator is now negative sine squared theta plus cosine squared theta. So it's still the same problem. This is still the same term as that. I've just flipped my sign. And the reason why I did that is because now you'll notice that both my signs, here, let me do this in yellow here. Both this sign is negative and this is negative, and this cosine is positive, and now its cosine is positive. So I actually have the same denominator now. In fact, just for that sake, let me write it in the same order too, so we can see that. Cosine. And I don't have to change anything on my left term. This is still a positive cosine squared theta. So let me rewrite my problem now. Let me rewrite my problem as I've simplified it. Keeping in mind that now I have cosine squared theta minus sine squared theta. All this is under. My numerator now is cosine squared theta, right? Here it is, cosine squared theta minus a sine squared theta. Minus a sine squared theta. And whew, to my relief, I have cosine squared theta minus sine squared theta over cosine squared theta minus sine squared theta. And as you well know, when my denominator is the same as my numerator, this all equals 1, which is exactly what the problem was asking for way over here in the beginning. So we are good. We have verified that identity. Okay. That was fun, right? So, make sure and watch this video again, because this was one of the harder ones. Make sure you go back and watch all those little tricks that we did. We didn't break any math rules. We just had to think really hard on what we could do. And, we had to dig deep into our tool belt to verify this identity. So please make sure you watch this one over again so that you can be familiar with those tools, so that you can dig them out whenever you need them in future problems. Problem 13 reads cosecant theta minus cotangent theta times cosecant theta plus cotangent theta, and this all has to equal 1, so we want to verify that. Well, looking at the left side, these are all they're all reciprocal properties, identities, but let's see what happens when we FOIL these, yeah? Let's see what happens when we FOIL them. So cosecant theta will go into these two terms, giving us cosecant squared theta plus cosecant theta times cotangent theta. Okay, and then next, this term, this negative cotangent, will FOIL into these terms, and that will give us, let's do this in blue again, minus cotangent theta cosecant theta, and then minus a cotangent squared theta. And as I look at this, I see here that I have a plus cosecant cotangent, and then I have a minus cosecant cotangent, which actually cancels out. And that leaves me with a very convenient cosecant squared theta minus cotangent squared theta. That did work out for us here. and this is also supposed to equal 1. So this actually resembles a lot of my Pythagorean theorem there of cotangent squared theta plus 1 equals cosecant squared theta. And what happened here is my cotangent was subtracted to both sides. And that's what ended up happening here, and that's how we ended up with this here. So yes, cosecant squared theta minus cotangent squared theta does in fact equal 1. So we were successful in verifying number 13. Okay, so I hope I didn't move too fast on that one. Please, again, go back and review, go back and watch the video, rewind, pause, whatever you have to do. But I simply used the FOIL method, and then I identified my result as Pythagorean identity. So let's look at number 15, the last one for this video here. 1 over sine theta plus 1 over 1 plus sine theta. And this is supposed to equal 2 secant squared theta. All right, so whenever I have fractions here, I want to find a common denominator. So that's what I want to do here. I'm going to do some scratch work here. I'm going to look at both of these denominators. I'm going to go ahead and multiply them out. I'm going to factor them together. 1 sine theta, 1 plus sine theta. All right, so factoring these out, or foiling these out, I mean, let's see what I end up with. I end up with 1 plus sine theta, and then when I factor this term into these two, I end up with minus sine theta minus a sine squared theta. So I realize that these cancel out, and that leaves me with a 1 minus a sine squared theta. Now keep in mind, again, all of this right here was scratch work to show me what I was going to get from my denominator here. So my problem now with a common denominator is 1 plus 1 over 1 minus sine squared theta. So the question is now, where do I move from here? And I look at what I'm supposed to end up with, secant squared theta. So I'm going to end up with the reciprocal there of secant, and the reciprocal of that would be cosine, or 1 over cosine. So cosine. So looking at my denominator here, I have 1 minus sine squared theta. That actually looks like I have a Pythagorean identity. So if I work out this side again, I have 2 over, 1 plus 1 is 2, over cosine squared theta. And cosine squared theta and secant squared theta are actually related to each other. And as you notice here, I have 2 divided by cosine squared theta. And if I move cosine over to the numerator, I end up with 2, let me write that here. I end up with 2 times 1 over cosine squared theta. And of course, I know that 1 over cosine squared theta is secant squared theta. So I was successful in verifying this. Okay. So the move that I think might seem confusing, I would think, was when I went from here to here. So keep in mind here, this cosine is in the denominator, right? And I wanted to move it to the numerator position. So I just simply multiplied it by the reciprocal, which is 1 over cosine squared theta. And that's how I got this right here. So it's 2 times 1 over cosine squared theta. So that's how I got from here, from the denominator to now the numerator, right to be alongside with 2. And I identified this as a reciprocal identity, and that is the cosine squared theta, which again matches what my objective was. Alright, so I hope these problems helped. The next video I'll be working out some of the word problems for you. Okay, good luck in your studying.